Welcome to this tutorial for beginner game developers, where we will explore implementing an event-driven game loop in Unity 3D. Our focus today is on how an enemy's death can trigger crucial UI and sound updates, enhancing the player experience. First, let's understand event-driven architecture, a design pattern where program flow is determined by events like user actions or system messages. This approach allows components to communicate asynchronously, leading to flexible and scalable systems. A key benefit is decoupling, which significantly reduces dependencies between different parts of your game. It also promotes modularity, making your code base easier to manage and improves scalability for adding new features without disrupting existing functionality. Think of it like a publish-subscribe pattern. Publishers trigger events without knowing who is listening, and subscribers react to events they are interested in. Now, let's begin by setting up our basic scene in the Unity editor. First, we'll create a simple enemy game object, such as a basic cube or sphere, to represent our target. Next, we'll add a UI text element to display the player's score. Finally, we need an audio source component in the scene to play sound effects when events occur. With our scene elements in place, let's move to Visual Studio to write the necessary C# scripts. We'll start by creating an eventmanager.cs script, which will serve as the central hub for managing and triggering all our game events. Inside Event Manager, we'll use delegates and events to establish a robust messaging system. This setup allows other scripts to subscribe to or trigger events without direct knowledge of each other. Next, we'll create enemy.cs to handle our enemy's behavior, including taking damage and triggering its death event. The enemy script will define a health variable and a take damage method. When the enemy's health reaches 0, it will call Event Manager, trigger enemy death, and then destroy itself. Now, let's create UIManager.cs, responsible for listening to the enemy death event and updating the score display. In UI Manager, we subscribe to the onEnemyDeath event, typically in the start or onEnable method. The updateScore method will then increment our score and update the UI text element. Finally, we'll implement SoundManager.cs to play a sound effect when an enemy dies. Similar to the UI Manager, the Sound Manager will subscribe to the onEnemyDeath event. Its playDeathSound method will then trigger the audio clip, providing auditory feedback. With all our scripts written, it's time to connect them and assign assets within the Unity Inspector. First, create an empty game object named Event Manager and attach our EventManager.cs script to it. For the UI Manager, attach the UIManager.cs script to the Canvas game object. Then, assign the text UI element to the score text variable in the inspector. Create an empty game object named Sound Manager, attach SoundManager.cs, and assign an audio clip for the death sound. Finally, attach the enemy.cs script to our enemy game object. Now let's see our event-driven system in action with a final demonstration. When we simulate the enemy's death, observe how the score updates on the UI. Simultaneously, a distinct sound effect plays, confirming the event was successfully handled by the Sound Manager. This demonstration clearly shows the power of event-driven architecture in creating responsive and modular game systems. For further polishing, consider adding a death animation to the enemy or implementing object pooling for performance optimization. You could also expand on this by implementing a more complex scoring system or different types of events. Event-driven architecture is a fundamental concept that will greatly benefit your game development journey. Thank you for joining this tutorial on implementing an event-driven game loop in Unity 3D.